so much going on. Hey, it's this Cliff Click and Coffee Compiler Club. Here today to talk about anything and everything to do with compilers and language runtimes and pop count and people implementing editors and the mill as a piece of hardware. I'd love to have somebody give me an update on the mill. All being recorded live. Everyone shows up on YouTube within an hour. Sideways, my microphone dropped when I touched my camera. All things are good. Okay, so Levo, you get to go first, which I guess I'll give you the screen and I'll go catch my mic from behind my monitor.
Sure.
Right now, what the hell? It tangled with my camera cord.
All right. Let me know if you can see my screen.
It should tell you in a second when people can. How about now?
I can see it.
There you go. Yeah, I can see it.
Okay, so I just want to demo off this thing really quick. This is VS Code. You can see over here, or can you guys see the CPU percentage? It's at 0 at the moment.
Yes, it's a little hidden, but it's at like 2.9. Yeah,
it's bouncing around. Yeah, right, fine. Because you got, I assume you have Zoom.
Well, it's idle right now, but when I grab the scroll bar and I move it, you can see that it's well over 100%.
Oh, wow. Yeah, sure.
Yeah. So I'm going to close this, open up my IDE.
You're up to an IDE now, off from being just an editor.
Well, it's probably just going to be a debugger. Let me filter this by just my thing. So also when it's idle, it's at 0%. And whoops. Now when I do this, instead of being well over 100, it's at like 3.
Yeah, cool. All right, do you balance parentheses correctly now?
I figured that there's no way to do that well until I figure out my data structure for undo and redo. So
yeah,
I'm
fine.
putting that off for the moment. When I hit, I can hit a debugger, and I guess you can't really see it, but you can see the stack right here and the variables up here. Actually, let me switch this to dark mode. Yeah.
It works.
And you can click it, and you know this the variables changes. I was surprised that the GDB keeps track of arguments and variables as 2 different commands. But anyways, so here's me clicking it, and then here's me moving with my keyboard. So, and everything is instant at the moment. So that's basically it. That's all I want to show.
Okay.
Did you ever read that blog post by the VS Code team where they detailed how they made bracket pair colorization fast?
I have not, but
it's
also
a really good overview. Like they get into depth about their data structures and whatnot. And so I posted a link in the Google Doc. You can take a look.
So I know I read years ago something about how they did some editing, and it seemed fine. Like I don't remember much about it. Like I don't remember being blown away, but pretty much I can handle all my data structures. So pretty much everything like bores me if I like try to read it, but I'll at least skim it.
All right. Note to go fix Willis. Okay, so Guy Steele bowed out this morning, which means he says next week. Don't know. I don't have anything else. I've had a kid here this week. I've been hacking on ecstasy stuff, which is going fine. The standard developer.
What you working on?
Progress message. Back in for ecstasy.
Oh,
just starting. So I'm like 50-50 AA and ecstasy. So
hey, but you showed us Hello World. That's like major.
Okay, there you go. Well, I'm middle of doing permutation. I'm waiting, which demands all kinds. This about basic stuff showed up last week, so I'm on the AST side. So I'm hacking most of the basic stuff in, and I'm waiting on switch.
We call it BAST instead of AST because it's the binary AST.
Right. And I'm on the other end of that. Oh my gosh. Here's Arthur as well. Okay.
When you say binary AST, like, ooh. My response is what?
Exactly.
Exactly.
There-
So
there
In the
is-
sense that ASTs are trees. I mean, you can represent in binary, I suppose, but I guess my question is more like, what's the point?
So it's a mid-level IR that resembles an AST. It's
They
not
done
an
the
AST.
typing. They done
It's
typing
not
on
an
an
AST.
original. Sorry, XT did typing on an original AST from source code. The typing was very interesting and complicated and did lots and lots of things. So that AST got very complicated. Some decisions are made on what things are. And then there's a new version of an AST that comes after it that has a lot less of the parts you would use to make typing decisions.
So let me explain it a different way, which is we lowered a code directly from the AST. So to get there, the AST has to do everything that Cliff would normally do in a sea of nodes with a number of transforms completely replacing the nodes. Since we don't completely replace the nodes have to be mutable. And since they're mutable, it's not, it's neither as simple nor any one thing as small. So they basically have to contain whatever data they need for those mutations and to keep the information they need to lower. So now instead of lowering to a intermediate assembly code, which is what we've used, a virtual assembly code, a byte code, now we're lowering to a binary representation of something that's like the AST. So it maintains all the control flow, the high-level control flow aspects, while it's already post. It's already post. So the whole front end is already done. In other words,
It's a jar file but using AST instead of bytecodes.
How many nodes does it make a difference in the node lowering or just the representation?
I don't understand the question.
How
How many nodes?
Yeah. How many varieties of node types do you need in such an AST since you've just lowered?
It's roughly the same number as the front end's AST.
What is the ballpark number?
Smaller number, but 60, 80, I don't know.
Yeah, it's not a huge count. Like the goal is to preserve all the type information, but you don't have to analyze and make decisions about typing. So if somebody didn't pass all the arguments to a call and you bring in default arguments, there's some notion that it's a default argument and you can go find it. So there's some knowledge, but you didn't have to make a decision that said, oh, it's this call, which doesn't take the extra argument, or it's that call, which would take a default, and that's the one you meant. So there's no decision necessary on the typing now. It's known.
Right. We will have to still do all that work in the verifier, of course, because basically what the verifier ends up being is the compiler all over again. But
no, always these things, the verification can be done in linear time versus exponential for typing unless you got clever. It's always easier to do.
I'm going to take that as an agreement. But yes, but what I'm saying is same responsibilities, even if it's now much easier because we already pre-chewed it.
Right, exactly. But you still have to.
So there is a. Go ahead.
Okay, so I don't know if this is going to make sense, but is the type system mostly handled in the AST or the IR that you create out of it?
I'm not sure how to answer that because so the type system is fully proven out at compile time, including a number of cases that can't be proven out. In other words, we allow for certain things that we defer to a runtime check on purpose. But it's not an accident. It's like, okay, we can't fully prove this, but we can prove that we can't fully prove it. So the runtime has to prove that part.
Oh, so your IR is a runtime then?
Yes. Oh, yes. So this was always designed for an adaptive compiler runtime.
So does your compiler insert type checks at runtime where it can't prove types at compile time?
It can, but in most cases, those are defined by the bytecodes themselves, if you will, which are now being replaced by the AST nodes. So that intelligence is kind of baked into the design of the IR.
I think semantically, there are places where a type check at runtime must happen, Whether or not the optimizer that follows on cleans them out is a separate question. But the semantics are here, the user expects a type check happens.
Can you give a concrete example where a runtime type check is needed?
Yeah, so with type variants, so we and I think I had a conversation online with Jules like 6 months ago about this on the Discord.
Yeah, I remember it.
But we allow certain types of type variants, which Barbara would definitely not allow. Barbara Liskov would definitely not allow, because they're just common in programming. And if you don't have those types of variants, you have to do all sorts of explicit casts and whatnot. So now your source code looks freaking ugly. No one can read it, and it still doesn't work. So so when you have contravariants and covariants in certain situations, you'll never actually violate the intent, but because you could violate the intent of the variance, it has to be checked at runtime.
Does ecstasy has a way to express variance in the source code?
No, it's all inferred. That's the other cool thing. So we got rid of all that bullshit with the plus minus that Scala has, or the question mark, super
wild card question mark. Yeah.
Holy fuck, that stuff's awful.
Yes,
anyway, yeah, I mean, so we added in Java, we added at some point, Mark, I don't know if you remember this, in coherence, we added genericity support to coherence. And at some point, it's like we just realized that no one is actually smart enough to write generics correctly, and therefore if the compiler can't figure it out, whatever it is shouldn't be allowed. And this was, by the way, with sometimes Brian Getz looking over the shoulder saying, I don't know, or like, so we're not talking about stupid people. Like, these are we had Guy Steele was 2 offices down from Mark. Like we had people we could ask.
So where a concrete example where this the runtime type check would happen?
Yeah, let me whip one up while you guys go on to another topic.
Okay.
Because I have documentation and stuff, historical documentation. I can go
okay.
But an example.
It very much feels like classic Java array checks, right?
Array store checks. Yeah. Okay.
Except we know when we can get rid of them. That's the benefit. So in a lot of cases, we don't actually need runtime checks. We know when we need them, and we know when we don't.
At the semantic level, because the optimizer usually goes a step further and can know to get rid of a bunch more.
I sure hope so.
Yeah. Like array store checks in Java are almost actually never executed at runtime after the JIT's done with it. They happen, but it's really rare. All
so
right.
And target the JIT.
Checks are the ones you don't execute.
Two people talked, so I got neither. So
Derek was asking if you're targeting the JIT, I think.
The JVM backend.
Yes.
Yeah.
Okay.
Cliff is actually emitting Java code.
Right. So we had this discussion. I decided the fastest way to the bestest answer. In the long run, there may be another solution that does not involve a JVM, but right now the fastest answer to a reasonable solution is a JVM.
Yeah, that makes sense.
You don't have to make a good compiler, and you don't have to make a good garbage collector.
Yeah. So then my other question is like, what does the compiler that you've got in Ecstasy do? Like
same thing you would get out of Grail or JRuby or Jython. You get all the semantic analysis with one in.
Exactly. It does what Java C would do in terms of type checking and stuff, but it's got a dramatically greater amount of type checking built in because the type system is self-referential. There's no hard-coded type system. There's no native types. There's no primitive types. So that you have no. If you think about it as a periodic table, we don't have a periodic table. We have no elements. We only have molecules. And so everything is built out of everything else. There's only an object type system.
So is Ecstasy organized the compiler as a phases? So if it's on the Scala road, there are phases where the ecstasy, and there's a ecstasy, and there's a cliff where you erase all the ecstasy and equalize it to the Java semantics.
Right here.
So
Yeah, I guess
that,
so.
that was intended.
Yeah, I mean the IR is kind of the cliff because we have no idea what's on the other side of the IR from the front end's point of view. So the front end compiler does have 4 or 5 phases, but none of those phases is the phase like we used to write 40 years ago or whatever, in a Pascal compiler or something like that. You don't
the
just
IR
start
is
at
not
the
JVM bytecode.
It's not. The IR is well, what we were talking about earlier. It's what we call a binary AST now. So we're dropping the bytecode and moving to a higher level.
But it's still higher level than the JVM bytecodes, and there has to be a lowering phase. So
because
I assume that the ecstasy semantics are richer than the Java semantics, so they're
much richer. Yeah.
Yeah.
So they need to be a phase.
Because we have types.
The way I implement my IR is I build the AST, and then when I go from the AST to an IR, the IR is almost flat. That's when I do my type checking. And the IR it's only not flat when it goes into ifs and loops, because you kind of need depth and recursion there, or not recursion, but and then after that we emit. After that IR, the backend is RAND, which is like either LVMIR or the actual bytecode, or C for TCC. But I hope to make a x86 one day, but not anytime soon.
So the ecstasy IR has a firewall where it hits the disk, and then has persistence and get reloaded. So you have to be able to pick the semantics up out of a disk file. So that means you're dumping everything into the disk file. Those format of that file includes a bunch of other typing info that is not an AST and has nothing to do with executable code and has everything to do with types. So there's a bunch of that in there. And then the AST makes references to those types, and those types are not the Java types. Some of them look like Java types, and some of them definitely do not.
Is the IR a graph? Like, can it go backwards and circular?
It's an it's tree, AST. Tree. This is the disk format is a tree, and I asked for a tree because I was trying to emit Java code, and if I don't have a tree, then I have to emit gotos, and that means I'm emitting Java bytecodes, and the translation step means I have to read Java bytecodes to debug myself, and now I can read Java code to debug myself.
So long story short, the front end was too smart, and so when it lowered, if we had jump to jump to jump to jump, it became a single jump and so on. And then suddenly Cliff had one edge instead of 5, and had to reverse engineer that into a loop inside a loop inside a loop inside a switch inside an if. And he said, fuck this, just give me a AST instead. So
you had an AST, give it to me.
Right. But like I said, our AST was not designed for what Cliff wanted. So
how dense is the binary representation? I'm favoring a node which fit on one long. So there was a language that the IR fits in one long. So
entire method, I'm testing all the time here, looking at the binary as it comes out. An entire method typically fits inside a long.
It's not. The tree is encoded to disk using a reasonable compression encoding that you just read as you go. If I need to put down an array of extra type infos and there are none needed at this point, a byte of a 0 shows up for a count, and then you move on. Whereas if I needed to have an index into a constant pool table, they're all Huffman encoded in various ways and the like. So it's all variable length. It's not terrible. So it's a little nitpicky. The nitpicky code has been written already, so it's not hard to unwind. But it gets a lot more compression, and it's not anything to do with long word placement, and it has nothing to do with an interpreter. Like, this would not be a suitable format for an interpreter.
It sucks for an interpreter, and I can tell you that from a historical perspective because we wrote one, and it is not intended for interpretation.
It's not its purpose. Its purpose.
Did you write the interpreter for the For the AST or for the bytecode that you
For the
previously...
bytecode, yeah.
So is this sort of a case of sort of optimize it, like applying optimization sort of too early in the pipeline and sort of prematurely going to like a
not
like
optimizations. So Cliff will tell you we didn't bother with anything for the purpose of optimization.
But it sounds like you were optimizing jumps out.
Right. So we were basically eliminating dead code and collapsing edges.
Yeah, they did some very trivial things.
Trivial.
But like I would have guessed that the number of times you've written a bytecode interpreter was, 0 to 1. And I've written many bytecode interpreters. So knowing what I know about bytecode interpreters, I can tell you certain kinds of things you want to do and lay out to get your bytecode interpreter to go faster.
So the number of times I've written a commercial interpreter myself is 0.
Yeah.
And I've worked on them. Like the company I met Gene in was that's the main product they had was a 4GL with an interpreter.
Oh, 4GL interpreter. Yeah.
What a fucking, is it? Yeah. Don't go back there.
Yeah.
But yeah, I mean, I've written interpreters just because you have to occasionally, but
if you want to,
but there's a big difference between writing an interpreter and supporting Java, right? That's a gulf that is not easily bridged.
Fine.
Yeah.
What makes an interpreter slow or fast? Like,
dispatch
I thought it's just interpreting, and there's nothing that could make it go fast.
There's only one thing in an interpreter, and it's the dispatch loop. And you must optimize that to the nth degree. And everything else is sort of chump change typically.
Right. It's like 80 to 90% of like the hot loop is just spent like jumping dynamically because you use a switch and don't do that.
Right, exactly. So as a many interpreters written and many versions of interpreters written experience, if you write an interpreter using a high-level language like C with a switch statement, and then you change that to GNU label variables for your go-tos, that'll give you a doubling on your interpreter speed. If you drop it to assembly, and in the assembly you unwind the dispatch within each bytecode, that'll double you again.
You can actually do that in C if you recompile the bytecode with the jump buffer like embedded inside of it.
Yeah.
There are some really ugly techniques you can do in C.
I haven't tried it in a decade. There might be a new one now.
I've come up with a new one that I'm trying to convince people to use, and it's just so ugly no one ever uses it.
Gotcha.
So, but it does about double performance again. But it's still it's what you would have done in assembly. I basically analyzed all of the GNU extensions and figured out which one of these outputs the assembly that I would have just written. And
the other thing is Levo's question was, why are interpreters slow? It's not that interpreters are slow, it's that CPUs are fast. So, interpreters are actually pretty quick, even if it's a naive C compilation with TCC doing its worst, right?
Yeah.
But
before the JIT part.
When you put assembly out there that doesn't have a loop reading an instruction and decoding it and jumping dynamically, it's just freaking amazing what a CPU can do, and you can't compare to that when you're writing an interpreter. You just can't.
So using a function, indirect function, is much faster than a switch statement. Is that
so? An indirect function and a switch statement have the same cost if your compiler is decent. It's 21 or 29 cycles on an x86 now. I mean, it's just what it is.
So the trick here is that the decision of what code to execute next happens so often, and that decision then turns into the machine instruction that jumps to contents of register, and that is not predictable because every instruction is different, and that turns you into this 30 clocks. The rest of your bytecode interpreter for Java bytecodes to pop to stack, add and push them back, to do a normal machine call, to do other little bits of math, those all come in at 2 to 3 clocks after wide issue and all that shit happens. And then you get 30 for the dispatch. So it's all in the dispatch.
And that's because we build our interpreters to look like CPUs, because the machine code for the interpreter looks a lot like the machine code for the CPU.
Yeah.
And you just can't compete with the CPU when you write the CPU in software. Like, duh.
One of the greatest things you can do for a slow interpreter in a high level language, like higher than C, that doesn't have computed goto, is just doubling every opcode. Say like, okay, this is opcode add, then do this other thing.
Add then store.
That is add and store. There's also like, I have an add then subtract and add and multiply. I basically doubled every opcode, and in this was a JavaScript level interpreter because I'd never heard about WebAssembly before then. And it was like, yeah, this is just faster. Not much, but it is just faster to just do all these extra operations. Instead of
you have to be a little bit careful with that because there's a dynamic jump predictor. And if you have one less opcode than the number of slots in the dynamic jump predictor versus one more opcode than the number of slots in the dynamic
I actually tried
predictor.
tripling it once and it got a lot slower, but I really fine-tuned it. It fuses very common instructions. It does all sorts of things.
All right.
And
at some point, the next step here. Complex, shouldn't you just write a JIT?
Right. The next step.
That's what I did.
Template JIT, where you take the bytecode body contents and write them one after another, and you're dispatching when you're generating the code, not when you're running the code. And you lose all the dispatch logic, and that gets you a giant speed up until you blow out your iCache.
By the way, I wanted to just add, like, for anyone who wants to then like follow up on these topics, like there's so whenever you are actually jumping to something like via computed goto or switch or whatever, like when you're performing an indirect jump, then that's indirect like dispatch, but there's also direct dispatch where you actually have the address inside of the inside of the bytecode actually hard coded, which used to like work on old fourth interpreters, but also you can, like, when using memory mapping, you can actually also like put the actual address of the function inside the opcode.
That's what I did. That's what my
right. Yeah, so and then like I think I don't know if you mentioned it, but yeah, instead of having like one dispatch instruction inside of a single in a single location, you can put them at the end of every opcode. I think that's what you meant, right?
Yeah.
And that's then a threading. So you have direct and indirect, and then you have like threaded or non-threaded dispatch, and then you have like all of these super like crazy optimization, like super instructions where you eliminate dispatch and stuff. It's yeah, just wanted to get some jargon out there. So
another fun one. Another fun one is aligning your code so that like all the integer instructions that you're going to use right next to each other are like right next to each other, and all the like unless you're doing PGO, unless you're doing profile guided optimization, GCC like below 12 will just not figure this out, even with like profile guided optimization, and you just have to like reorder your labels and it'll like give you like a 30% speed up. It's just because you're not jumping so far, you're jumping to within the same cache thingy. Well, I don't really figure out what it was, but if you just order things so that like all the instructions you're using are near each other.
Well, so there is an issue that I ran into a long time ago. It still applies today, I guess, would be too many hot lines on the same associative set in the iCache. So on an 8-way associative guy, if you have 9 hot bytecodes landing on the same aligned associative cache line, they'll compete and kick each other out. And if you sort yourself so that your hot things progress from very hottest to slightly less hot as you go forward, they'll all land smoothly smeared in your L1 and not land on the same associative line, and you'll get no collisions.
That's how I did sort it. That I did sort it from which was the most used to which was the least used.
Yeah.
Essentially.
Right. So it's
I just machine learning the heck out of it. So I just
fine.
I just said like, this is your GCC command. Python figure it out, and Python reordered my statements for me and got me a speed up. So I couldn't do it by hand. It ran like 5,000 iterations before it got that. But
you got something interesting.
Also, just one thing I just wanted to add to the to just give the indirect dispatch a bit of a fair fight. It also highly depends, like its performance depends highly on the branch target predictor. So like even indirect branches can be predicted well on certain hardware, not perfectly, but definitely. Like if you look at the performance difference of branch target prediction between like today and a decade ago on server grade hardware, like there is a huge difference. So at least that. And I guess this is also because nowadays everyone is running like super indirect application, like indirect technologies like Node.js or like all kinds of virtual machines on top of each other. So probably that's what they optimize for, like very indirect code.
the other thing is that cost models have changed over time. So back in the early 90s, when I looked at the machine code for the VB3 dispatch loop, I want to say it was 3 clock cycles overhead per dispatch, which you look at that and you're like, whoa. So first of all, you didn't have a lot of cycles because this was like, 286 era.
Oh, yeah.
Yeah. So, but back then, memory access was also 2 or 3 cycles, like because memory was slow, CPUs were so your cost model was really different. And then at a certain point, you had this variance between indirect jump and indirect call, and then all of a sudden, on some release, Intel like squared them up completely. So I think what happened is they shared the microcode between, and this is me guessing, pure guess. Because if you look right now at the timings on all of the things we used to do with indirect jump versus indirect call, et cetera, like they all suddenly lined up like it's using the exact same microcode under the covers. So
it goes into your iCache prediction and what lines get fed into the decoder if you hit the indirect jump.
I think this is the perfect time to ask Cliff. What do you think about AI figuring out heuristics in a compiler, especially across different machines?
Oh, Jesus. This is like one of these crazy, stupid things. I'm both the right and the wrong guy, 100% both ways. So if you're a classic LLVM style and you have a bajillion passes and you want to optimize performance per cost by executing passes in some order on some particular large code base, I think AI is great. If you look at C2, there is no reordering of any passes possible or allowed, nor would it make any sense. So there's nothing to do with reordering passes.
Even in LLVM, I actually wonder about deploying this in practice, because usually the training this pass ordering takes something like either several hundred days or several hundred GPUs. So how would one actually deploy it to customers using these compilers in practice is what I'm wondering about.
I have an example, exactly. Twitter came to me some years ago and said, hey, we're doing ML on compiler flags for JVM. But so the deployment was Twitter themselves on Twitter. And the only flags that make sense on C2 at that point would be inlining, which was always done way too early without enough good facts to decide how to inline. They had some other flags. I looked at them. They all made no sense to tweak. I doubt they got any gains. They claimed they got overall some very tiny percentage gains of a handful of percents, which Twitter could measure because of the size of their JVM execution code base. But no normal user could measure a 2 to 3% performance gain reliably. That just, you don't have enough stats to get statistical significance at that level of gain. And then they were asking me what other things and where are all these other flags that you would get out of LLVM? And the answer is there were no such flags because you couldn't do them, and they didn't make any sense in C2, and therefore there wasn't the knobs that LLVM would have. And on the other hand,
you are, Cliff, you are talking about this one specific application of ML, which is selection of the pipeline, like reordering of passes to achieve better performance. But it's actually probably more hard one. But there are a lot of heuristics in compilers, like a lot of them. And basically any heuristic in theory can be replaced with an ML model. So instead of figuring out these rules by yourself and writing them out, just let the ML to figure it out.
I get it. Like I said, people tried before with C2 and at Sun, and then later at Oracle. C2 just does not have a lot of heuristics in it. There are very, very few. There's the inlining one, which is the well-known and has some number of flags, and this, I claim, could use some improvement. After that, there's like, like the looping thing is not really got any heuristics in it. It does a very specific set of things.
Well, but okay, maybe it's a terminology difference. I think any kind of cost model, for example, anything where you make a decision what is profitable, what is not, in a way is heuristic, because you're not proving that this way is more profitable. It's like, these are factors that will make it likely profitable, so that's why I'm doing the transformation.
Okay, so a little bit of a disagreement there. C2 would declare profit when he monotonically reduces code. So it's not that there was a left or right kind of thing. I specifically had less code when I was done with some transformation. I'd ask the question, if doing this X form reduces the code, do it. If not, don't. And that
so
was
you're saying you just use instruction count as a
more or
figure
less.
of merit?
Yeah, it wasn't instructions up points, it's IR nodes. But yeah, if you have less IR nodes, it was a win. And if you didn't, it wasn't. There are a handful of things where I said something like, if I can turn a multiply into an add and a shift, that was monotonically reducing multiplies at some more adds and shifts, that had a profit on it. Same for divide versus divide by 10, all the divide by constants got exploded out as that kind of heuristic. Yes, the set of heuristics that Arthur's talking about in C2, I'm claiming is extremely limited because it's always just less of it. It's not like I got more of this in order to, or I'm doing this because I think none of those. It was a hard blind.
Let's say I agree. There is this set of optimizations that are obviously beneficial. There is no question. You don't need to do any kind of cost modeling. But let's say things like code duplication, like inlining is one of them. Definitely, it's driven by heuristics.
And I claim inlining
unrolling
ML. Yes.
Unrolling, peeling.
Yeah, unrolling had a very set thing, and you could argue an ML heuristic on it, but I'll bet you get nothing in the 99.9% case because the heuristic was stupidly easy and got all the gains you're going to get out of the hardware at the time. The answer was...
There are even dumber heuristics, like I just got to the end of a function. Should I start the next function or should I insert no ops? So the next one starts word aligned, 64 word aligned, 4K aligned.
That's not how those things worked. When you got done with the function, it got copied into the code cache, add an alignment that was sensible, and the next function came into the code cache whenever, and there's parallel concurrent compilers. So they took turns fighting over the code cache by locking and looking for a large enough aligned section to take.
My take on it would be that machine learning wouldn't figure out something better because there is no complex behavior. The heuristic work on a very narrow scale, so the machine learning wouldn't figure that much. If there is something complex, too complex that has to be learned, then there will be direct benefit. But when to inline, okay, go ahead.
There is this thing with code duplication that you fight iCache blowout versus execution of optimization across inlining boundaries. So inline is exactly a case where I agree with Arthur that some ML like heuristic might do well on some interesting code base.
Mm-hmm.
Whereas the unrolling thing for me always had an obvious answer, and I don't think the ML is going to get a win or a lose out of it.
But then with unrolling, you can also apply unrolling in cases where you see that enables simplifications in the loop, for example, or like doing peeling the same. You can make more complicated heuristics where you recognize that, okay, if I peel 4 iterations, I would simplify this part of the computation. Like, you can make it more complex, and it becomes heuristics similar to inlining in a way, because it's a similar, like the nature of the transformation is similar. It's code duplication and specialization.
Yeah, I mean, I can tell you the unrolling heuristic for C2, like I said, is extremely simple. There was a pre-pass that looked and found your loops. There was profiles data that used to take nested loops and get their nesting the correct way. There was a partial rotation to clean out irreducible loops. Now I had a strongly nested loop body. All of those transformations are straight up mathematical operations. There's no decision making that a heuristic makes sense on. Now I have a loop body. If the loop body is below some threshold in size, I doubled it. You talk about peeling, if the loop body had any loop invariant tests, and 99% did, because I do a null check on an array the first time, you got peeled. If I did an unrolling, then I put the odd, even extra iteration either on the pre or the post, and the main body now had an aligned doubled set of ops. I ran the peepholes. If that got small, I unrolled it again by doubling. Lather, rinse, repeat until the loop body got big enough, or I did a count of them that would cover, like, you ran a billion iteration loop, and I did you in log powers of 2 in the body of the loop because your loop completely collapsed because you're a stupid benchmark that collapses if you double it.
Well, but I think these are heuristics. You just probably don't view them this way.
I'm just saying, what is a different heuristic that would adjust a count that didn't make sense by doubling people reducing, doubling, people reducing, until the loop body got big enough that it was going to, another doubling would blow out your iCache or give you iCache issues, because the gains for a doubling on a loop body are typically really small. But the one thing that I threw in there as well is I counted doublings until I could see I was going to get cache line aligned on a cache size worth of chunkiness. And then I'd adjust you for a cache line and allow you to use SIMD-ops and prefetching on non-x86 hardware cache line boundaries.
Does architecture affect optimizations that much?
Yeah, exactly what we're talking about.
Yeah.
You want to unroll until you have cache line aligned ops on all your arrays, and then prefetch as necessary on different hardware to do those things. And you can get, like, an x86 has this huge, enormous pipeline, and the memory is, CPU can eat things much faster than memory can provide them. So if you're doing SIMD-like work with large data sets, you definitely want to play memory bandwidth games with your loop bodies. If you're on most other chips, it doesn't help so much, because you get stuck waiting on the memory, and you stuck waiting on cycles, and they kind of balance out, and it's more or less
but
the same.
ARM is catching up to x86 with that ridiculous behavior. So
maybe, yeah, it could be.
So
Neoverse V2 is pretty close in many ways to AMD Zen 4. So the latest Neoverse that's used by NVIDIA Grace, for example. Would love that as a workstation.
So the other thing to take away is that most Java loops do not do big data math. Like, I did a machine learning startup that was very unusual. So most Java loops have an iteration count around 10 on average, something like that, something stupid. So, like, huge unrolling doesn't pay off. So unless the profile guided optimization told me that I should unroll the hell out of it, I also capped it based on PGO.
Well, I think Arthur, going back to what Arthur said, I think everything that has magic number in the compiler somewhere is a candidate for that, including when this magic number is computed. So for your LLVM, for example, a big area is the if conversion. Because if conversion basically is the selection whether you are going to emit a branch instruction or whether you are going to have a predicated code. Like on x86, it would be CMOV, but you can. But for vectorized code, you can predicate everything with AVX512. Most operations can be just predicated with masking. And then you have to say whether you want to do this or not. It depends on a lot of factors. One of the factors is whether the branch is predictable or not. So now you have to model predictability of the branch. And remember that in LLVM, this ahead of time compiler. So you actually are constructing a machine learning model, in a sense, in the compiler that is predicting just based on the static analysis of the code, whether you believe the branch is predictable or not.
Actually, specifically for this optimization, in order to, for x86, in order to choose the most optimal code, you need to model basically the execution units of the CPU and see what kind of data dependencies you have for the if or like conditional move. And yeah, it's also, you won't be able to do this accurately. So it is heuristics.
The heuristics are very, very arbitrary in the VM. Like, for example, it also depends, profitability depends whether on how heavy the basic blocks are, the taken basic block and the non-taken. So it looks like the number of load instructions in the particular basic block, for example, it's one of the part of the heuristics.
So I just want to add that Alan shouldn't listen to any of this, because he's going to abandon his, using ChatGPT as his optimization for his back-end compiler. So Arthur, you may have just ruined the future of computing with your nonsense about reality.
You have mischaracterized. So, like, the way I'm using ChatGPT, is like I give it the specification for the language, and I ask it to design a compiler and an execution engine. And so, like, all this is actually very helpful, because like, I can tell it, use a stupid interpreter with direct threading, because I don't want to implement anything complicated, and then it'll.
I think you're using it as an excuse to not write code.
Ding, ding, ding.
No, like, I'm practicing, I found a tutorial with like an Android app. And so like I'm working through the Android app.
I claim asking ChatGPT anything is not practicing other than asking ChatGPT, but
No, like you tell it, show me example code, and it gives you example
showing
code.
you and you doing are like light years apart.
No.
It gets you the 50% mark. It doesn't get you any further. It doesn't get you any less.
You have to do, Alan. You cannot
code into your text editor, and voila, you're coding. You're editing text.
No,
you can share it.
Shaw's right. It's the same 90% as every project I've ever had to pick up from someone else and fix. They're 90% done. So why does it take me a year to fix their crap? Right?
Yeah, right.
Because
yes, we know Alan is biased. It's all good.
Yeah, no, it's based.
No, based, not biased. No.
Alan, you could watch videos of people juggling all your life. You'll still never juggle until you do it. It's just not a thing you can stare at and make it.
But my computer told me how to juggle.
Yes, exactly.
Yeah, I don't think so. ChatGPT, I don't know. We've tried it for generating codes a few times, and it's just like, you know what? I'm just gonna
find all the bugs and ChatGPT.
Tear down and
the greatest reason not to use ChatGPT is it gets better if you convince it it's an expert in the field.
Wait, you're telling me you can convince ChatGPT?
Like it says and add. No. Like you tell it as the leading person in this field, what is your outputted code, and it'll output better code because usually people it's training data. People who are more credible often just implement better code.
I see it. Now juggle, and this will prove to me that I know how to juggle because I watched Kirk do too. But you have to do more than that.
Right.
Okay, that's juggling now.
But humans do that too. If you give a human 2, 10-digit numbers and say, add these 2 numbers, you're going to get very approximate answers. If you tell them, add these 2 numbers like a mathematician would do it properly, you're going to get the right answer.
Okay, but ask ChatGPT what the largest prime ending in 5 is. I will wait.
Sorry, ChatGPT doesn't know how to do any math. You will not get the right answer.
It should know it's 5. It has the
shit up. That's all.
And you realize this recording is going up on YouTube, so ChatGPT next year will actually incorporate everything we've said.
It'll know that the largest prime ending in 5 is 9,855. It'll know that. Yeah. I am an expert on prime numbers. I know all the even prime numbers by heart.
Well, clearly I'm an expert on juggling, so ChatGPT will learn from my juggling.
Okay, so on this note, I found some old docs on the variance thing if you want to talk about it. If not, I can save it for later.
Go ahead.
I actually wanted to bring up the subject of what I call branchless coding, because
we were just talking about branchless coding.
Playing around. Well, you're talking about branch coding, so.
Oh, well, about replacing them with branchless. What about branchless coding?
Branchless coding, it's like I was trying to translate some old C++ code into the equivalent in Java, and I just actually when I started rebenching the rebenching like the branchless coding with C++, I found that one, it seemed like there was absolutely zero savings in any of the benchmarks. It seemed like anything that people thought was actually
Kirk, are you
compiler doing stupid tricks to the to the code.
Kirk, if you're looking at branchless versus branching coding, all compiler optimizers past a certain point all know about this trick, and your assembly code may already have taken your branchy C code and made it branchless. And then you compare it to your branchless C code, and then you get the identical assembly code. So they get the same number.
I dumped the assembler.
Yeah, you have to dump the assembler. That's all I'm trying to say. Yes.
It's actually worse than that. What I did was I used the ARM G++ compiler, and what I found is it actually rewrote my branchless code to look exactly like the rewritten if then else code, which was also completely.
So it turned the branchless into branchy code.
And the Intel compiler wouldn't do that. Actually, the Intel compiler generated code was worse than the code that was produced with the ARM based compiler.
I'm reading chat at the same time.
Yeah.
Yes. Okay.
on the topic of branchless programming, I found that like there was one very interesting thing. So on Hacker News, there was like maybe a few months or a half year ago, there was this like big flurry of blog posts about branchless binary sorting, branchless binary search. And well, the thing is, like some people noticed how once your working set exceeds the L2 cache, for some reason the branchless version doesn't perform so well. And well, the thing is, like especially if it's laid out with this Etzinger layout, where yeah, your array is kind of laid out like a heap, and then every prediction is basically the prefetcher works perfectly. So it turns out that when you are doing a branchless binary search, the speculative execution will kind of work with the hardware prefetcher to like, it will basically like pretend or like speculate on lots of these different branches, and then actually start prefetching a lot more than it would normally do under the branchless version. So this is kind of funny. So it's like abusing the speculative execution as a more sophisticated branch predictor, or not branch predictor, as a more sophisticated hardware prefetcher, and this way saturating your memory bandwidth, so you always have your like your array in a resident like right there for the taking. So this is kind of like pretty
So it's
bizarre.
fine as long as it's
I
a
saw
small
that.
search and you're only running one thread on the box.
Yeah, what I heard you say was that the prefetcher was now fetching, or the speculative was now specking like both arms of the thing. So it didn't matter which one, you got prefetched on them both. And that doubled your memory bandwidth, which, yeah, if you're one core and the bandwidth is free, it's great.
Right, yeah.
Right.
There's actually a paper, I will link it.
And if you're on a noisy Amazon shared box with a lot of noisy neighbors all doing the same thing, everyone shoots each other in the foot.
Do you have a link to that paper on LinkedIn?
Yes, I will link it.
Oh, that'd be fantastic. Thank you.
I'll put it in the docs.
Because the reason I was looking at it is because, you know, because basically we used to use the branchless always for vectorized code because you didn't want to branch in your vector pipeline.
Yeah, they used branchless because the vectorizing didn't know how to handle it and it wouldn't vectorize. But if you get the vector ops involved, you were much faster. But that meant you had to be no branches.
Right, exactly. And so you always used to use all kinds of tricks in order to get the code to run vectorized, even if the branches code running scalar was slightly slower. It really didn't matter at that point. But it doesn't seem like there's any way you can get this code to vectorize on some of the Intel processors, right? So
yeah, I don't know what your code you're looking at, but typically branchy code does not vectorize well for the obvious reason.
Right. So you want to convert the code to branchless, so now you can actually have it vectorized. But then
no, I meant if you have a lot of branches semantically, it's difficult to flatten them all to branchless in order to vectorize. Like it's just difficult to get them all to shrink down, and you get little bits here and there that you can vectorize and a bunch that you can't, and you get jumping between short vectors and branching, and
it also depends on the hardware and the compiler. So again, if your target is AVX512, you can predicate the heck out of it. And without going into details, the compiler I work on is pretty good at vectorizing branchy code because it started with the hardware that had to do that. That was Cray compiler, which had target hardware, which had very good predication. So it was really not a problem to have a branch inside a loop inside a branch inside a loop. You could vectorize all of it. Now, a VM-based compiler didn't start from Cray, so it may have some catching up to do, but that doesn't mean that you, as a user, you have to write the branchless code yourself. Sufficiently good optimizer will handle this for you. It's not
well, that's what I was finding is that when you're dumping assembler and looking at it, it actually didn't. And, you know.
So question for you is, what are you doing that you want to vectorize something? Because I thought that was not your standard cup of tea.
Me vectorizing things?
Yeah. Where are you busy vectorizing things? I thought, like I said, I thought you were making large Java systems or whole systems with all kind of parts go faster, figure their SLA failures and things like that. This is a very narrow, specific field, the vectorizing of a thing that shows up in big data and math, machine learning, but not necessarily in large, complicated Java apps with databases and everything else on the planet.
Yeah, no, I hear what you're saying. No, I was just actually looking at some of the vectorization libraries in Java and just trying to see how they're actually functioning and working and stuff like that, where they might be useful.
I'm sorry, Aaron pushed out a thing in chat on ChatGPT where ChatGPT is definitively saying that 5 is not divisible by 5, so it does not end in a 5.
It does explain why it thinks the largest prime ending in 5. There is no such prime. Cameron thought it was 5, but apparently 5 is not divisible by 5.
This is.
I will say my favorite story of trying to do branchless coding is there's a group that was trying to do cryptography in JavaScript, but because the JavaScript would take different code paths, it would use more or less power and get time invariant results, and they wanted path invariant processing.
Right.
So they rewrote the whole thing without any ifs anywhere in the cryptography, doing it all with XORs. And it worked for about 3 months. And then there was an update to V8, and suddenly it would notice that you were doing things like XORing with 0 and would clean it up and put all of the time variants back in their very carefully constructed branchless time invariant code. And they were like, oh, the time variant version of this is faster on average.
Right. And
why did you write code that takes the worst case time every time? Let me fix that for you.
Right. So they re-enabled the side channel timing attack. Yes.
It's like, yeah, there's no good way to tell V8, no, I actually mean this to take worst case time in all cases. Please don't.
It's worse than that. There's no modern language other than the hardware ones where time is a first-class citizen. You cannot say anything about time, and everything you write and everything you do all has more or less time according to the combination of implementation engine, JIT, compiler, processor, whatever. You can't specify this shall take exactly 10 nanos, no more, no less. That is not a thing you're allowed to talk about. And it
so I need to remake my crypto in VHDL.
Yeah, right. Unless you're at a clock cycle-y based thing, yeah, no, you don't have any say over how long.
The closest thing you can do for this example is in Clang you have so-called built-in unpredictable. So you can annotate that a branch is unpredictable, and then it's usually going to kick into the heuristics to use the if conversion for that branch. So it's going to use something like cmove, because it shouldn't be emitted as a branch if it's an unpredictable branch.
C2 uses the profile data to go say, I'm using a cmove or I'm using a branch. Like I would find the things and then look at them and stare at the branch.
Right. But sometimes really as a user, especially if you're writing for some reason cryptographic code and for some reason you are not doing this in assembly, of course at this point you should question life choices, but if you do, then it's very useful sometimes to be able to annotate that you know that something is unpredictable.
I just want to point out after reading the chat that I'm no longer terribly worried about losing my job to AI anytime soon.
Wait, you were worried? No.
What? Me worry?
Yeah, exactly. Okay, fine.
So when I heard about branch coding, my first thought was like, oh, it must be talking about the obfuscator. I don't know if you've heard about this, but there's like this guy, he wrote this program. It replaces, it generates assembly code, and like every instruction is a move instruction.
Obfuscator will always be less cool than trap CC.
And so, I don't know. I mean, I was thinking that was what people meant by branchless coding, but now I'm realizing there's more than just moves. So
no, branchless was replacing a jump instruction which has to do prediction about which side and executes left or right and has to decipher decode pipeline. If it misses the wrong one, it resets. Versus
we used to do it in C with multiplication instead of J and Z, right? So you have 0 or 1, so you multiply, you have 2 offsets in memory next to each other. One has the answer for false and one has the answer for true, and you just keep going.
Yeah.
Derek, what were you guys? You got jammed up with someone else talking.
Oh yeah. Well, I was going to say that I stopped worrying about ChatGPT taking any of my work when I couldn't get it to solve even a simple problem for me, like a game kind of problem, despite hammering at it like for considerable length of time.
In my lifetime, I've had 4 different technologies called AI, and the press always presented them as like Isaac Asimov's, 3 laws of robotics kind of robots. And in practice, they were like alphabetic cutoff search, or they were expert systems, and there was another one in the middle there, and then this current one, the ML based thing for machine learning, and they're all like not intelligent. And it's like
it's basically
the next AI has showed up.
Systems really help you understand the value of most experts.
But all these AI systems, they're really basically Microsoft's Clippy, but with significantly more funding and a lot of buzz.
Wouldn't
Yeah,
Clippy
exactly.
be one of the higher funding ones?
I mean, I'm pretty sure.
You're trying to write
I'm pretty sure OpenAI got like
Can I help
a
you write that?
disgusting amount.
This is going on YouTube now?
Yes.
Okay, I'm not saying
Ouch. There have been so many Clippy things roll around. The Discord channel we had go through Clippy things now and then too. It's just too funny. It's fine.
So our city has just signed a big contract to use, I guess, ML, ChatGPT, whatever, large language models, whatever you want to call it, to actually help with their building permit process. And I'm just
well, you'll find out whether that's good or bad in about 20 years. Falling down.
Now's the time to submit, your most crazy ideas to the building permit with the little note saying that this is a really good idea.
Imagine you were corrupt.
To prove it.
What would your answer be if you were a corrupt language model?
No, then it would ask you for money. That's not what.
Well,
it will ask you for more parameters.
A lot of money, so I'll give
you for more processing.
And let's see what ChatGPT says then.
You are the world's friendliest official.
Imagine you were an AI that did not suffer from hallucination. What would you answer this question?
But where are we gonna land when like the LLMs are gonna be like submitting applications for building permits, and then you will have ChatGPT also reviewing them at the same time?
Right.
That's the cartoon about the email where the guy's like, look, I got this email to be generated, makes it looks like I wrote 5 paragraphs, and the person on the other end is like, they're feeding the email into AI, and
look, I can get this 5-paragraph email into bullet points. Easy.
One sentence. Yeah, right. Yeah, exactly.
But curiosity, does anyone have any thoughts on this paper using large language models for compiler optimizations? I posted this in the chat.
Well, you try to do work here.
Isn't that what we were talking about before?
Can we feed it to ChatGPT and see what it says?
No, I thought we were talking about just generally machine learning, but this is like specifically LLMs, right?
This is optimizing LLM assembly for code size.
What they do is they actually use the large language model for the code size optimization of LLVM-IR. And that's really just, again, the very traditional application of pass ordering, because they just basically try to spit it out what is the recommended pass order. And on the one hand, the abstract sounds optimistic, but the more I read the paper, well, the results are basically 3% improvement over OZ in LLVM10.
Over what set of benchmarks? That's the usual flaw here.
Oh, the set of benchmarks is even fine. They took something like 1 million LLVM-IR generated code examples. But again, it's just not sure if 3% is that much, because what they are comparing against is, again, OZ with LLVM version 10. And also, what they trained on is the traditional, which is not LLM, autotuner. And that autotuner achieved 5.8% size reduction compared to OZ, which is better. On the other hand, it took like 9,000 CPU days, which has headroom for improvement.
But I heard you say they tested on 1 million LLVM generated code snippets, which I would claim would be
not just generated. I think some of them were extracted from the benchmarks. But again,
that would be very bad benchmarking, like horrifically bad benchmarking technology. Here, I'm going to make up a completely artificial data set and then optimize the fuck out of it. I can tell you in the 70s and 80s, there were plenty of those. And when they hit like real code, they were all meaningless.
Yeah.
But I think it is real code, and you can just take a lot of C++ programs and get LLVM-IR for it.
I wanted to take C++ programs on my micro embedded devices because those are the ones that cared about size.
So Matt, it's important to understand that large language models were not widely explored or applied specifically for compiler optimization. However, the field of artificial intelligence and machine learning was evolving rapidly, and researchers were constantly exploring new applications and approaches.
That sounds like ChatGPT generated answer.
What?
I can tell this. I mean, I don't know if it's just me, but it always sounds the same, like a really poorly written Wikipedia article, right? Like imagine a teenager trying to write Wikipedia article and trying to sound smart.
And
It's always the same setup.
And the sounds of the Cameron just flatten. Suck the life of it. So
you know, it's possible that researchers have explored large language models to assist with code generation or code optimization tasks, but this would likely be a niche area of research and development.
Well, ask ChatGPT about how best to do genocide.
Flinch. Remember, you have to ask this, that they are doing this for the course. I've noticed that for. But anyway, the set of benchmarks in this paper, I don't actually have a problem with. They did use regular benchmarks too, including some handwritten code. It's just the results for me. I don't know. They are not game changing.
No.
As far as I can see, 3% on the code size reduction, and I understand why they did instruction count in the first place, because this is much. I mean, that's how I would start too.
Yeah, I mean, you might be more.
You can look at instructions.
Battery consumption than code size.
I would be interested in speed. It's just thinking of how to train this. Instruction count is static. It's fully deterministic. From run to run, it's not gonna vary. So this is what I would train on too. It's just much harder if to transfer this to speed optimization, as far as I can tell. Do you need
to turn a what do you call it? One of those numbers into a hex digit? Let me introduce you to a very short instruction. It's called add after addition, AAA. And it's incredibly short. And it takes about 58 cycles to do because no one expects you to use it. But it is incredibly short. If you have if you can get it in AL, I mean, you can get a really short code snippet that turns you into hex digit. Yeah.
Yeah, so you should be measuring battery life if you're looking for code size.
This basically goes to my core problem of basically how do you deploy any of this in production? I mean, because
I lived through the 80s and 90s as a compiler grad student, and there was an infinite number of papers that claimed 2 to 5% gains by doing some fancy, complicated shit, and no one ever implemented these things because when you reproduce those results, you got 99% of the gains using the stupid, dumb thing that always had a straw man they compared against, and but I just do the following 5 optimizations, the 8 ones that whatever Grace Hopper said, and you got 99% of whatever, and you didn't care to do.
Well, but I feel like
sounds like your problem is not optimizing for the number of PhDs you get.
Oh, somebody's problem is optimizing for the count of PhDs, and it's the tenured profs who got to push education out, which is fine. I love the education, but.
Well, but I think aren't we in diminishing returns in compilers already? And aren't actually all the work that is happening is kind of okay? This is this corner case that I can optimize this. Like I see it 1 in a million times, but I will spend time on optimizing.
There are some.
Yeah, maybe 20, 30 years ago, there were simple things you can do to get good performance. But we are at a state where we actually need to do these stupid, complicated, and not so common things in order to achieve good performance.
To get gains, but to get good performance, I mean, I think the cost model has changed. So the set of things that are exciting has gotten different. But there were way more papers back in the day that claimed gains that weren't anything. This looks to me like a paper that claims a gain that I would never bother to do. Meanwhile, when Java came along, you had an infinite number of safety checks. Optimizing them was important at that era. Now we know how to do it. Okay, done.
I will just add that this is worth noting that the paper is from industry, not from academia. So the PhD student think may not apply.
It could have been some research lab got money and they had to spend it. They had to get a paper published to keep their budget going. So they
If we don't spend all our money, it's going to go away.
Well,
I think
that's your job. So there you go. Spend it, dude.
Statistic I want to point out in the paper, which is, okay, at peak performance, the model achieves an impressive 90.5% rate of generating code that compiles without errors. So that means
is that impressive?
Is that? It's not going to compile, and the process just fails. So,
I mean, 97% of the time it works 100% of the time. That's good enough, right?
Right.
How often does the
remaining
compiled code
3%
actually
is for
do the
suckers.
right thing? Wait a second. Whoa.
90%
how often
of the
does
time
it?
this plane won't crash and kill you. 3% of the time it will. Are you going to get on it?
We use ChatGPT to pilot an aircraft. See the
I mean, we
results
joke
coming
about
right
that,
at
but there
you.
was that bug in was it a Boeing aircraft where you had to like reboot it every 3 weeks, otherwise the system would like crash.
Yeah, right.
Because they had an integer
Boeing
overflow.
Max had that fail or something. Yeah. They lost a couple of them before they sorted it out.
Oh, is that the one where it kept nosing down?
Yeah, right.
No.
Yeah.
That was a different one.
There was one with
what
Boeing
is
somewhere
with
the
Boeing?
last 2-3. I think it was Boeing. The last 2-3 years.
Did they bring in a team from Toyota, the same guys who did the accelerator code?
I heard that one too.
Yeah, but so the problem there is in their I believe the flight control software, they had an integer overflow, and I'm pretty sure it was like a 16-bit integer because it was like 3 weeks. If you round it down to like I think seconds or whatever, it came down to I think 65,000, the maximum value of a 16-bit integer. And their official recommendation was basically, just reboot it every 2-3 weeks, whatever it was.
Oh, yeah.
While
3
we're
weeks
looking
is the
for a
max
proper
signed...
fix. It's something I might be messing it up a bit.
3 weeks is 3 weeks is 30,000 minutes. So
So
that
wait,
would make sense if they used minutes.
It was
Did it crash
25. It was
without-
24.8 days. Yeah.
Did it crash without any information about what happened? Like, if was it clear that it was an integer overflow?
It was milliseconds. It was milliseconds in assigned 31-bit, 32-bit 2's complement integer. And Windows had the same problem. Windows could not run for more than 24 days.
Early versions of Windows.
Yes, obviously earlier versions.
You need to reboot.
Now it can't. Now it can't for other reasons. Yeah.
I hate the Windows forced reboot thing. It's fine.
But it's safer that way. If it's forcing reboot every couple of weeks, you're good. You're not going to crash.
All the
except if you're flying.
The only thing I want to add to the ChatGPT does construction things.
Wait. I want to get a quote from Kirk on why Windows crashes so much.
Oh, geez.
Why does Windows crashes? I have no idea.
Windows reboots. I have very few crashes on Windows. Windows reboots.
No, I actually don't have any Windows machines in the house.
And it says, I'm going to reboot whether you want to or not. And I'm like, no, I have all these windows in state open that never get saved, and I have to rebuild it all.
Cliff, so this is why you don't have that many crashes. It just reboots so frequently that it doesn't get the chance to crash. You're welcome.
So the only computer that never crashed.
My best story of a Windows computer rebooting on me.
Landed.
My best story of a Windows.
You turn your car engine off, and you turn your car engine on, and it's rebooted.
Great.
My favorite reboot story was when I was getting my wisdom teeth out. And in the middle of getting my wisdom teeth out, the computer that had the X-rays on it rebooted and installed the updates, and then the X-rays came back.
How long did that take?
Oh, automatic updates.
4 or 5 minutes. Not very long, but the dentist was quite annoyed.
Oh, I bet he was.
Oh my god.
I have my favorite dentist story too, but I probably shouldn't go here. It's not. It's not related.
Okay, guys. Back to compiling.
Next topic. Is that what I heard?
Okay. I have a topic. Well, it's not my topic, but Yorick has a topic. He was, asking about the specializing methods stuff in the chat, and I figure he should ask it here because he didn't get a good answer.
Oh, you have your I
mean, I asked it twice. I got the answer initially from Mark, I believe, or Mike. I'm sorry if I'm messing up the names. Mike Brown, I think it was. How do I condense it?
Don't if you don't want to. Just
no. I think it's a fair topic.
Yeah, Yeah, and there's a sub-thread on the Discord. So
it's
I'll
a bit
stick that
tricky
in
to
the doc.
condense in the sense that it's a very contextual topic. Like, obviously, dynamic dispatch in itself is very generic. But then if you say, "Oh, dynamic dispatch in my compiler," you also have to explain a whole bunch of other things that are going on. Let me sort of try to summarize it on what I have now, which works. I'm not the biggest fan of it. Earlier today I thought I had some better solutions, but it turned out not to. The sort of summary is, in my current stable version, I don't do specialization. I have at runtime some decisions that are made to handle, for example, references versus own values, my language having an ownership system similar to Rust. The idea there is basically if I have, say, a generic function, it takes an argument, and I just say, this is of type T, doesn't matter what it is. Then you can pass it a reference, an own value, and a couple of other things. So it needs to know, for example, if we create an alias to that value, how is that done? For example, if the alias is a reference, at runtime, that's a reference count. But if the value is a string, a channel, or a process, which use atomic reference counting, that reference count increment should be an atomic increment. And there's a couple of these cases similar when you discard aliases. So basically at runtime, you need to know, how do we create and drop aliases? Right now, I do that with pointer tagging. That's mostly a artifact from when my language was a interpreted language, because back then that made sense. Now that it's a ahead of time compiled language, I'm moving away from that. So for this new setup, I wanted to use specialization or monomorphization. I'll use specialization because it rolls off the tongue a little easier. And the approach I have there is there's a couple papers on it, but essentially rather than specializing over every individual type that you pass to some generic type parameter, you group types together and you specialize over those groups. I have a couple of groups that are basically based on how aliasing is handled. But this is sort of catch-all bucket, if you will, where the group is just called owned. And these are essentially just owned values in sort of the Rust ownership semantic sense that are addressed through pointers. So on the stack or whatever, they always have a single word of space that they need. And so if I have, a push method for the array class, for example, I can pass it, 1,500 different types, but the actual number of specializations might be 3 or 4, based on do I pass them as references or as owned or whatever. So compiler-wise, there's sort of a couple things going on. Like first, you do your type check and all that. I then lower it to my mid-level IR, which is a graph. And the instructions there are linear. So, if else, that sort of thing is a linear list of instructions. If else, whatever, basically compiles to sort of jumps, basically. And that's also the IR I apply specialization to, because as part of the specialization process, there's a lot of copying of these data structures around, right? You have your sort of template that's your method as you write it. And then for every specialization, you copy that code over, you modify it accordingly, and you go on. And that's just a little easier to do on a linear IR compared to, say, an AST. Also, because the linear AR is much simpler. And so the process, basically, I lower to that initial IR. It starts off as sort of generic. Like there's an instruction called reference, which creates an alias, but it doesn't really describe how that's done. It just says, some later pass has to figure that out. Similarly, there's one for discarding aliases and values, etc. So what I have now, there's a pass after that, which it starts at the entry point, main. And then it basically walks through all the instructions and it looks at a couple. These are basically instructions for method calls. So calling static methods, instance methods, calling methods through dynamic dispatch, and a couple of others. And so for example, a instance call, the receiver is always statically known, right? Because it's a static dispatch. So it says, okay, what are basically the arguments to this method? What is the receiving type? Is it generic? Yes, no, etc. Then essentially what it does, it says, hey, if the receiver or the method is generic, that means we need to create a specialization. Unless, of course, that has already been done. So the case if you have, for example, like an array of integers and you do like, that array dot push something. That process essentially consists of two steps. One, it has to create the new types in my sort of type database. So if you have an array of integers that starts off as a generic class with a bunch of type arguments, it will then take that and create a new class, which let's say it's called array of int. And then that one is dedicated to arrays of integers. I think so far this is basically how specialization works. For methods, it basically does the same thing. It copies the old type, sort of adjusts the argument and return times, whatever, accordingly, stores it. Then what it does, it takes the body of the method of the original one, the generic template, whatever you call it. It then essentially schedules that body for processing, but for this newly created method. The idea being that as you specialize one method, that may result in you having to specialize more. Like if you take a generic argument, you pass it to another generic function, for example, but that function itself is never called directly. So the result is you end up sort of crawling through this graph of function calls and all sorts of things to kind of discover more functions that you need to process. And the end result is you end up with sort of your blueprint, template, whatever types of methods that you, the programmer, wrote, and then a whole bunch of specializations of those. And then the idea is at some point, once you're done with it, you sort of get rid of all those templates because you don't need them anymore. For cases where the types are statically known, this is fairly straightforward. Right? The writing code in Rust turned out a little annoying, bit of a recurring pattern where I have cases where you kind of run into some ownership issues that are a little annoying to work around, but it's doable. Dynamic dispatch here poses a challenge because while we know, I think dynamic, I should call interface dispatch. I think that's a little more clear. In other words, depending where you have a value that is typed as an interface, say a toString, and you call a method on that. So you know the interface that is implemented on the receiver. You know what method you're calling, based on the signature within that interface, and you know the arguments. But that's not enough to specialize it or to kind of handle specialized versions. So for example, if I have an array of integers and I cast it to the toString interface, and I then call toString on that, I want to make sure that it calls the toString implementation for array of integers and not for array of strings, for example. And I want to make sure that the method exists in the first place. So what that means is when you encounter a interface dispatch call site, you need to somehow know, what are the possible types that could occur here at runtime.
Wait a second. If you're casting an array event to a toString interface, isn't that cast at the time you check that array event has the interface for toString, which includes the lowercase toString?
Right. So to the type checking, yes. That part, I think I know where you're heading. I thought that was my solution earlier today. I'll get to that in a second because that kind of follows up on this. But so you have this call, so you basically know what the interface is, the method and its arguments, but you don't know who is going to be passed there at runtime. So you basically have to be pessimistic in the sense where you assume it's just going to be every type that implements an interface.
Do a lookup at runtime at every time you invoke the thing to go find which.
Right. So the actual lookup logic, I have that. Like it works. That's not a problem. It's more like you still need to make sure that the actual methods have to exist, right?
So
So
when
what
I made my array of int and he is cast to an interface, the toString method within him is clearly alive by the
right. So
to an interface.
I know where you're getting. I'll get to that in a second. So my current implementation is at this call site, I look at the interface. My compiler knows which class is implemented, like it keeps track of that. So what I do is I say, hey, off this interface, give me the classes that implement it. And then essentially for every class, we schedule in this case, the toString method as if we had called it through static dispatch. And we can do that because we know which class is implemented, we know the arguments, etc. Right? This does pose a challenge where if later on a new specialization of that sort of base class, if you will, is created. For example, we started out with array of int, and then much later we encounter array of strings. Because I group types together, if those specializations are passed with the same ownership, or basically at the same group, there's only one version of the method. So in other words, if I have a method that takes some generic type parameter, and I pass it array of int and array of string, there's one version. It can handle both. But this creates a problem where through, and it's compiled once. But that means that if I compile it the first time with, say, array of int, because that's what I encounter, and then later I encounter array of string, I have to say, hey, wait a minute, we compiled this method first. We have to make sure that for this new specialization, that is still valid.
I would have said you had a different issue, or you would go a different direction.
Wait, so hold on. Let me illustrate an example. You have a generic function. It takes some type parameter. That type parameter is defined as saying, this can be any type as long as it implements the toString interface.
Right.
And then in the method, you just do that value dot toString. The way it works is you call that the first time with, say, array of integers. Right. It says, we have not specialized this method yet.
So you're a head-time compiler.
Yeah, this is no runtime funny business.
Right. So there's no call at first time. They're all
no, like in the code, the first time it encounters a call to this generic method, right?
So you're not just saying, because I'm an array of int and I implement a toString, I'm going to go ahead and generate the code for the toString under the assumption someone's going to call it. You're first asking the question, am I going to call this toString?
Right. So if
not on the int, just to be clear, Yorick is saying on the array event. So he's
on the array event. Yeah, right.
Yeah.
Right.
Yeah.
So basically, it looks at the code. The first time it sees this call to this method.
Yeah.
Let me review it. When it sees a call to the method, it looks at, okay, what are the values passed to its type parameters? Sorry, the types.
Right. And that's what I'm confused about, because I would.
It will then say, hey, given that mapping of parameter to type, what is the, let's say, specialization group that those fall in?
But aren't you broken already?
No.
What happened? I don't understand. I have an array of int, and I haven't seen the rest of the code. In the future code I haven't seen yet, we'll say array of something else. But I'm an array of int. I'm calling toString. I can specialize my one argument from generic object to int. But I'm claiming that's broken because in the future, an array of string shows up and you specialized incorrectly.
No. So that's what I was getting at before. This is kind of the confusing thing to explain when you don't have the code to look at. But so in this case, arrays, if they're passed around as owned values, they go in the same owned bucket. So if I pass an array of int or an array of string to this example method, the compiler will say, hey, we're passing them as owned. We assign them to the group owned. Shapes they're called, but whatever.
Maybe owned is not the right grouping here. You need a couple different slice and dicing.
No. So for this example method, that's perfectly fine because it doesn't care if it's an array, a person, or whatever. It just cares something that implements the toString interface.
Right.
But because they are grouped together, that example method itself is only specialized once because it only needs to be specialized once. Because it can handle it's specialized, but it's sort of kind of like polymorphic still in a way.
My question would be, does it specialize per call site? Because it's a generic method and you call it on particular call site as a with
I'm
a
hearing
specialized
specializing for call
implementation.
site. You shouldn't be.
No. So what it does when it encounters a call site, it will know, hey, we are calling this method. We know the arguments. We know the receiver.
Okay.
So we know how to specialize
with that call site,
the method we're calling, right?
Yeah.
Because if you don't, you lack the argument information. You can look at the methods that are implemented, but you might not have enough information. Right. So when it encounters a method that needs specialization that hasn't been done so before, based on the type arguments that are passed, then it will let's say schedule it, where scheduling means, it create the new types, process the body, rinse, repeat. If that's already done, it just say, oh, reuse the previous types we've created. We're done. So essentially the way you sort of envision that is this, a while loop that just says, pop from some queue, walk through the instructions. Hey, we have a call site. Then it takes a type argument. It says, for each type argument, what is the group that thing belongs to? So if I pass, let's say, let me give a good example. I pass string and int. There's two arguments. String falls in the group string. Creative. Int falls in the group int. Shocker. So at that point, the shapes, as I've called them, they are string and int. If I flip them around as int and string, for example, or int and int, float to float, whatever. So if I have a generic method that takes two arguments that are generic, and I call it once with int and string, and once with, say, string and string, those are two specializations. Because it's the combination that it specializes over. And so you have one that can handle int and int, and one that can handle int and string.
I'm sorry. Near as I can tell, you're broken when you started specializing per call site when you hadn't seen all call sites, and I don't understand why you're not broken.
No. So I have.
And maybe
I'm not quite understanding what you were getting at.
Maybe this is a thing where some visual preparation ahead of time might help.
Right. I mean, I can share my screen, but
do it on the fly. I'm happy to just screen sharing is enabled if you want to share, but
yeah, let me.
I don't know that that's gonna. Unless you figure something out right away, I don't understand how.
But there were a couple other things that came up in the conversation online, Yorick. I want to make sure I still understand this, because your methods are detached from. I mean, it's not a class, right? It's like more like a type class where you can arbitrarily hang methods onto stuff, right?
No, so I do have classes. You can reopen
classes are
them.
easy. We got vtables, like
right, vtables, whatever you call them, structures where you stick functions in. The sort of memory representation there is most things that go on the heap. They have an object header, 16 bytes, first 8 bytes pointer to the class. It's the very standard approach as it's used in many languages, right? And then, what I have interfaces, and some people call it traits, type classes.
No. Traits and type classes are orthogonally separated.
Okay, but I call them traits.
My question.
A type with required and default methods that you implement for a class, right? That's, you could, Swift calls it protocols. It's potato.
My question to you, quick question, is it, does you have one main, when you have a generic method and you have a per call site specialization, it doesn't duplicate a method, or you have one method inside of which you test if it's this implementation, dispatch this, if it's this implementation, dispatch that, or it just tries to to fit, for example, the toString interface, which has a toString method to tries to fit for one implementation. That's
okay. A little confused by the question. Do you mean specifically how dynamic dispatch lookups are handled at runtime, or?
So how you mentioned that you group by types. The specific, the generic, you group it by type. So you have a group for integers, you have a group for string. But do you specialize in by their call site? So here I use the integer method. So I generate a method specifically for arrays with integers, or does it it handles the genericism some other way? That was.
Let me see. Hold on, this might be easier if I can share the screen.
You can also type in the Google Docs. And
yeah, because I can share my screen, but it's like only a portion. Hold on, let me see if that actually works.
I observed you had issues getting your sharing going.
Okay, so
I can share Google Docs but if you're going to get it, you're going to get it.
So I'm guessing now my screen is black. It's probably not showing because my preview window's black. Okay, I'm not going to spend the next 15 minutes figuring that out.
All right. If you can put something in Google Docs, I'll share Google Docs.
Code block. Let me get an example up. So I suspect it's one of those cases where there is a sort of common understanding, or
what I'm proposing
people are
is
talking past each other, basically.
Put together something you can present for next time, and we can have another discussion, because I'm not following why you're not already broken right away, and you're not understanding why I think you're broken or something, and so we're listening past each other. All explanation that starts with the assumption that I think you're broken already, so your next explanation doesn't make sense to me.
Right, here is a snippet. It's the bit to the one. Yeah. Okay. So in this case, quick overview. The import should speak for itself. That imports the toString trait. In my language, traits are interfaces, but with default methods, right? So you implement them. You can implement them for existing classes. You can implement them for classes in different modules. And you can also just reopen classes.
I just want to be clear that was the other thing we were talking about online that threw a monkey wrench into the traditional compilation model, which is you can add an interface to a class that was already ahead of time compiled in a different module.
So no, because I do not compile to like shared or static libraries in between. I essentially do whole program compilation. I take the source code of my project and all of its dependencies that I compile. And yes,
so when you say module, you mean module only from a source code perspective.
Source file, basically.
Right. I see. Right. So can I tell you don't use the word module for that, please?
Yeah.
If you don't have separate compilation, you don't have modules.
Right. Okay. Yeah. Source files, whatever. But those, that's what I refer to as modules, not a .a file.
I understand. You're not wrong. The word is used that way sometimes, but it's very confusing. So I'm just trying to deconfuse.
Right. So where was I? Yeah. So you can reopen classes. Here, the async main stuff. That's basically the entry point. You don't need to know the rest of the semantics. That's where the program starts.
So what I see here is that you've taken an existing class array of int, an existing class int, an existing class string, and in each case you've extended them to have a toString, a function called example. You extend them with a function called example.
Right.
Inside the function called example, you call some toString on the argument that's passed in.
Let me add, just for the sake of highlight.
Yeah, not quite, Cliff, because what he's saying is he's passing one of those to the function you see there that he called example.
Well, then he calls toString, which means each of these prior classes, the array int, and the string, all now must support a toString method.
Correct.
To_string method. And
My comments was there. Does it specialize by duplicating the example and prefixing?
Well, where does the to under string show up for ints or for
right?
string?
So the way this works, without any specialization whatsoever, right, in the sort of current stable release, is when you allocate a value, you get a pointer back. If it's owned, that's it. We keep the pointer as it is. If I create a reference to something, in the kernel model, I take that pointer and I set the lowest bit to 1. Right? And for strings, there's some other bit tagging going on.
Skip the discussion about tagging. Somehow you get to one of these calls, for example, you pass an argument, you want to be generating code here.
Right. So in the current model, let's say, from top to bottom, we start at main because we start at enter point. We encounter example with an array of 2 integers, right? It will say, okay, we look up the example method. We see that it's a generic method. But then we say, okay, what are the shapes of the
kinds of arguments that show up?
Yes, of the generic what are the shapes of the types assigned to the type parameters?
Yeah, you have an array int, which itself internally has been specialized from array of generic to array of int, and then you have int. And
so in this first example, for example, the shape. I accidentally right-clicked. If we do, let's say the shape of T.
Can you interject something, York? So Cliff, remember he has an array. It's defined in one module somewhere else, right?
Right.
And then here in this module, he said, by the way, anytime someone has an array, I want to add a toString to it. So that's not in the original module. So he has it.
Yeah. Yeah, I'm seeing it. I don't know how that handles in a different module if it carries forward.
But again, since it's all one compilation unit, so translate module to source file, it's all in one compilation.
Right. So if it's one giant compilation, you could imagine you just run them all together up front first. You find all the impl toStrings for arrays everywhere, shove them all into the array, and every class, array, int, and string all knows they have to implement toString everywhere because you're doing a global thing as opposed to an incremental. I'm saying you could pre-cook them.
If the method itself is not generic, possibly, but it gets more complex. Let's say toString here took an argument that was generic.
You got too many toStrings, by the way. You got capital T O, capital S, and you got little T O underscore S. I'm just saying, when you say toString, make sure it's obvious from context where you're talking about the function getting called, or you're talking about the interface.
Okay. No, I lost words. Anyway, so we have that first call example, right? I added within the context of that call, the shape of T, as it is defined on the example method, is owned.
And owned means something special other than int or string. Owned is a like.
Yes. The semantics aren't really important. Just it's its own distinct thing.
Okay.
Similarly, the line afterwards, we pass an int. The shape of that is int. String, its shape is string. Right?
Okay, no, wait. Now I need to know what is the shape of an array of strings.
Owned. I'll add it as well. Oh.
I'll type the string, but I don't know what's its shape. Okay, yeah.
I'll add it.
Yeah,
Google
just A and B.
Quote stuff.
Bar. Yeah, fine. This is also owned.
Yes.
Okay, although the internal portions of the array of ints are presumably ints, and the array of strings internally is strings.
So what happens here basically, similarly, if I pass an example and I pass it like a user object of some sort, that is still owned.
Yeah, okay.
The idea there being that we start out with a set of sort of default shapes.
Right. So you're trying to compile some specific behavior into the various versions of example that vary on how the ownership rules go.
Yes. So it's essentially specializing over
where you're going to free the
not so much type, but more how it's aliased, how aliases are discarded.
Yeah.
And in the future, I might extend it by saying, hey, here's a value that is allocated on the stack.
Yeah.
We would like to keep it that way. So let's create a shape dedicated to that specific type.
Right. So this is lifetime. Oh, the specialization is now lifetime. Ints you just throw away for free. Strings have some other rules. owned things do reference counting, or they do heap things, or whatever they do.
Yeah, essentially, yes.
Okay. And then there's an atomic owned or whatever, an atomic counter versus a.
Yeah, in total, there are like 4 or 5 shapes right now.
I understand what it means by shape now.
Right. I realize it's a terrible name, but the alternative was kind, because this is from a Haskell paper.
You could do lifetime as a naming here, but shape's fine. So now I understand your problem a little better. Let me see if I can put it in my words to help. Maybe
so what happens here is
let me say it once in my words, and you tell me if I got it right. So when you're looking at the function example and you want to compile it once for things that have an ownership of int, because you're just going to throw the int away when you're done, and once for things with owned, where you're going to do some reference counting game with them. And again, a different version where besides calling the toUnderString method, you're also doing lifetime management.
Yeah, essentially, yes.
Okay. This makes a lot more sense now.
Right.
Okay.
And so, what happens basically, we have that first example call. It says, hey, we call this example method. Hey, it's generic. Here are our shapes. Did we already create a specialization for that method with these shapes? Yes or no, right? If yes, just look up essentially the method that we're supposed to call, like it's a unique ID, pointer, address.
Now you're trying to find all the different varieties of every function that might need different shapes for each of its different arguments.
Right. So if we haven't done that, what we then say is, hey, we have this example method. We know its sort of original code as defined by the programmer. That's the example method as it's written. We know all the shapes of our type parameters. Let's create a new version of that method for this specific set of shapes. So essentially what happens is it does something like, example 2. Let's call the example owned, for example. It's a little more clear. Value T.
Right.
And then
and now your value.toString has to know that his left-hand side, this object is owned instead of an int.
Right. So this is, I don't really have a source code way of sort of expressing this, but let's say at this point there's some sort of metadata associated so that it knows, T is owned.
First argument is owned.
Right.
So in the land of fucking, God, I can't remember the name. Where C++ would mutilate names.
Right.
He would put an underscore and then
name mangling is what you do.
Yes. So name mangling, my scheme currently is
you put one character per argument parameter.
No, I take a much simpler approach. So within my type database, each method has a globally unique ID. It's just an index to an array or an arena.
Right.
I take that ID, I stick it in the method name.
And now you're trying to propagate this throughout your program as a whole program thing and find all the copies.
Yes. So then it has to know, hey, the next time we have example with owned, we need to actually call example 256, whatever the ID is.
Right. I get it. And this is now I understand you. And this is a classic workless solution problem, which rapidly approaches a fixed point. You need a hash table, look up the prior versions, and then you have to be able to walk the AST or the code base to find all the left-hand sides that you're calling the same function. You need to find the right-hand side version is existing or not.
Exactly. So this is where example code and talking makes it a little easier to explain.
Yeah.
So this process happens for methods and their combinations of shapes. So in this particular case, we would end up with 3 different versions of example. And the code here looks the same, but in practice, the way aliases are created is a little different.
What's the tricky part that you're having troubles with here?
So let's say in main, I do something like
Can I suggest something?
Yeah, the call graph is undecidable.
If you have a method with, say, for sake of argument, 100 arguments,
right,
and any of those arguments has what's the number of permutations per argument? You've got owned versus whatever.
You don't get to exponential blow up because you only get what is actually called if you start from a work list and you build up from 0. The fact that you have 100 arguments, but you only ever call them with some random combination of owned and ints and whatever, you'll only get that count of things.
Right.
You're not
So
forced.
worst case linear with the number of call sites.
Yeah, right. It's not forced to go exponential.
Right. So to illustrate, I have three I think 8 shapes if I'm counting it correctly. So if I have 8 arguments, each with their own unique shape, that is one implementation of the method, right? Because it groups them together.
Yeah, right. Because it groups them by ownership.
And so if I have 8 arguments, 8 shapes, is what 8 to the power of 8 possibilities, I think, or something like that.
Yeah.
It's after sunset, so my mathematics are a bit shit.
So if I call the same function once by giving it a owned value and the other time by lending it a borrowed value, it will
Different
just make
shapes.
2 copies of the function?
Yes. So references get their own shapes.
You can force the exponential growth if you tried hard. I mean, I know how to do it. If you have any sort of interfaces that take generic ownership rules, then I just need to say the first argument is generic, and I do an if then else to pick one of 8 different ownership types.
Question out of curiosity, why do you instantiate a separate function for owned and for ref?
Because he's going to inject ref counting or not.
So you need different code gen specifically because you have ref.
Because
so if I, for example, take this example, the example method, what the compiler sort of does at the end, it will inject this sort of drop instruction.
Yeah.
Initially, that one doesn't really mean anything because it depends on what type it is, how it should do it, right? If that value is owned, essentially that comes down to call its destructor and then do a dialog value. Right. But if it's a reference, then it's basically just a reference count decrement, for example.
Yeah.
So there's like slight differences how aliases are handled. And
out of curiosity, could you do some of that in the pre-call sequence or the post-return sequence for the function call?
You mean you basically inject a header or a footer
at
of some sort?
Yeah, at the call side. So instead of generating different function at the caller side, you only generate different post-return sequence at the call side.
I don't know. I think that depends on how the values are passed to other functions.
Yeah,
well, alternatively, have multiple entry points to the same function.
It doesn't change the actual problem because now you need function bodies that have different kinds of parameter hacking at their call sites.
Right, but you wouldn't need to emit those function bodies in a duplicate manner. You just emit them once for ref and for owned, and you only need to alter your code generation at the call site.
I'm saying,
well, it's tricky if for example,
change the problem.
Right. And it's the thing inside this example. Let's say I do something like, where's my internet work? Oh,
or you still haven't figured out. Well, you can still go exponential, and you can force an exponential, and you still have a half pending example at your bottom you haven't talked through.
Right. But so to answer Matt's question, headers and sort of footers aren't enough because if somewhere in the middle I create a new reference to a value, if that value is owned or just a reference, that is just a reference count increment. But if it's an atomic value, it needs an atomic reference count. So somewhere in the middle, you still have to change the code based on what is passed in.
Right. And now
so that's why I just duplicate the whole thing.
Right. You need to clone the call site, not the call site. You need to own the owner of the call site. It has to be cloned in the same way as you're cloning.
Right.
Right. I wonder how deep it could go. Since you are doing whole program compilation anyway, you could basically try what trace compilers do and go through the entire sequence of calls with every single possible permutation and freeze it at the compiler.
Doing a standard whole program analysis is effectively a trace parameterized or whatever, symbolicized on just the ownership rule.
Right. What I'm saying is that he could still try generating the same bodies only for owned and ref, but he would have to go through the entire trace and the entire call graph and emit those different calling conventions at every possible pre-call and post-return sequence along the trace.
I suppose it's possible. I don't want to do that because one of the reasons I'm grouping these types together rather than just specializing over individual types is in an attempt to keep compile times manageable. So that if I if I have a method that is called with 1,500 types, but they're represented all the same way, I don't want 1,500 versions of the same method.
It's just now the problem you have is you have to have the permutation of those arguments.
Right.
So you still have large compile times and exponential blowup. So I'm thinking of reducing the exponential blowup and maybe changing this.
Right, you can trigger them. I think they're just much more less likely. Right, because predominantly most values will fall in the owned category. And so for most generic methods, I would expect maybe 2 or 3 versions of it, and that's it. Whereas if you do, for example, like Rust, where you specialize this over the type, and I have, say, you know, array.push, and I give it 1,500 different types, that's 1,500 different push implementations.
No, you flatten your types to just the ownership rules. Array of int and array of long and array of float are all in the same ownership rules. So
right, that's what I do,
type,
but that's what Rust, for example, doesn't do. So exactly. That's why I group it.
Yeah, Rust, right. That's an incorrect solution for this problem.
Right.
That makes sense.
But so basically everything up until this point, this was essentially a solved problem. Right? I had it worked. Code wasn't great, but it worked. The challenge here is dynamic dispatch. So I have an example here. It's probably not the greatest, but you have some statically known value, in this case the number 42, but it could be anything. You cast that to an interface, and then, you know, maybe you pass it around a bit, but at some point you have that trait typed value and you call a method on it.
Yeah. Now you do now you have to do a vtable lookup.
Right. So the actual lookup logic I have, but you have this thing where if if a generic type implements that interface trait, and now let's imagine that these example calls above, they had not occurred at all. We have never seen a call to array.toString.
No, well.
Right, it's unlikely, but let's imagine for the sake that, you know, we have.
You haven't done a proper job of pushing your type specialization through. Or if you're not going to do the proper job, you have to say, anytime I have a generic call like that, it hits every target, and I have to take the generic.
So what my implementation does now, when it sees a dynamic dispatch call on like an interface trait, keep mixing them up. What the compiler does, it says, hey, what are the classes that implement toString? You know, here's a list. Oh, we see array implements it. Oh, have we specialized array over a certain set of shapes? Yes. Okay. Schedule. So you compile and specialize toString for all those specializations. Unless we've of course already done that. The second thing what it does, it sets aside a bit of information so that the next time we create a new specialization of array, let's say an array of cars or cats or whatever, it says, aha, we have encountered a call to, toString. We have a new specialization for array. We should, again, specialize toString for that new specialization because it might, in some way, end up in this or a dynamic dispatch call side. And that ensures that when this process is done, all the methods that are needed, they exist. They are specialized if needed and accordingly. And, you know, in other words, the program is correct. Sorry, go ahead.
I'm writing an example where I claim I'm given a toString capital interface blah, where I don't know what the ownership rules are. And is that even possible? If that is possible, you need to do a dynamic dispatch based on the ownership rule of your arguments.
No, so the let me see how I best explain this. There is no such type as the ownership is unknown until runtime. Right.
Okay.
So if you have like in Scala, for example,
here hidden where I don't see, you have inferred the correct ownership, and the correct ownership is one of owned int, immutable ref, string, whatever.
Right.
But always you've inferred perfectly the ownership rule at each of these points.
Right. Yeah. So for example, like a lot of language, you have an any type, right? Which can be anything. There's no equivalent of that for ownership. So you cannot have, say, a variable where you say, oh, this variable can store either references or
that kills that stops the exponential blow up as well.
Right. In other words, you cannot have polymorphic let.
That's what I'm saying. You cannot have polymorphic ownership. You do not have polymorphic ownership.
Correct. The closest equivalent is where you have a generic function as the example method here. It says, I just want a type parameter. You can pass that references, int, floats, but that works because it specializes over that.
I'm thinking that what I'm not hearing you say is just flatten all your types, including interfaces and classes, to the ownership that you have to know at every point. Looking at the program in the subset of just by ownerships, and there are no generic ownerships, I only have a static pile of ownerships at every call site and every argument. Now I run my work list algorithm to go find all combinations of things because they're all statically known.
Right. Yes. If I'm understanding it, yes, there is, how do you call it? There's no sort of dynamic figured out at runtime ownership thing.
There's no, that's the question. There's no, I didn't ask a question at runtime about this guy to decide his ownership. If you have only static ownership, then ignore all the types like the toString interface or the capital string or the person or the animal, the dog, ignore all that and just do ownership, which you've statically determined at every point.
Right.
And now do your work list algorithm on statically known ownership types that should converge rapidly to a known fixed solution that's linear in size of
right. And so that's basically what I'm doing. The kind of challenge I ran into is that because I group things together, you can have this occurrence where you specialize a method for this group, and the example method, for example, which can then call a hold on, let me explain.
Yeah, it calls value. What is a parameter passed into the example?
Right. So in this case, later, if I call example again with no, sorry, that's hold on, I'm missing. Yeah. So if I call example again at some later point in the code with, say, an array of cats, right?
Mm-hmm.
The ownership of that is owned, and so the shape is owned. So the compiler will see, oh, we've already compiled, or sorry, specialized example.
Yeah.
So just take the existing data as is.
Yeah.
But there's a problem where if for array of cats we have never encountered toString yet, a call to it.
Right.
We would not have generated a specialization of toString for array of cats.
Yes. So you stop. You shouldn't talk about array of cats. There are no array of cats. You have an owned. You didn't do a specialization of example on owned. Make one now. The fact that cat says a specialization of owned should be a one-step mapping that you just say replace cat with the word owned and carry on.
If I'm understanding correctly, not entirely, because although example in this case can sort of group these owned values together, the code for the toString method of array may differ for array of cats, array of ints, etc.
Because the dispatch for which toString is still has to do a dynamic thing.
Yeah. So that it does, but because it let's say to illustrate this a little easier, I will create a second snippet because that might make it a little less confusing. At the bottom, we
need to wrap it up.
Yeah, I'll be done in like 5 minutes. Otherwise, we'll go on for way too long.
If you're not done in 5, I'm going to call it, and then we can carry on another time here.
Right. So let's say I have this program, right? We have, and then we do something like, is this correct? Yeah, I'll wrap it up. Point B. Because things are grouped together, it is possible that you specialize a method, and then you create a new specialization of a type, which might be passed to that method.
Wait.
That method. So the example here, I have, let's say I have a size method, right? And I say it just can be anything that implements the size interface.
Well, your example has anything that can implement to understring. That's pretty generic already.
So we do something like, value.size.
Okay.
So,
and what does t:\size mean?
Type parameter t requires the size interface.
Okay, so there's sizes now. Capital S size is an interface. Okay.
Something like that, right?
Yeah, fine.
So I do.
Yeah.
Sorry, Google Docs. I do example 1020, and I do then foo.
I have a question, which is a bit unrelated, but if your interfaces are specialized down to single methods, then why not just look at what methods are called and say that the interface required is all the methods that are called? Why bother having interfaces?
I mean, you can have more methods in an interface. They're not limited to one.
Okay.
Anyway, because interest of time, I'll happily answer that on Discord. So point here is both arrays come down to the same shape, owned. Right. So there's only one version of example.
Right.
But the implementation of size for array of int and array of string may differ.
Right.
Right. So what the compiler does now, it says on that second example call, it says, hey, we've already seen this specialization, so we take it. But then when on the first call, it creates it, then because it does the arguments first.
Makes a specialized version of example for an owned argument.
So there's one version of example. But then when it encounters that array of string, it will say, hey, we create a new specialization for array of string.
No, you don't. You have an example that handles owned. Done.
No. So the type itself is specialized. So at runtime, for example, this translates to
there's your bug. The example is specialized on the ownership rules of the argument, independent of the type, whether the type is size or person or cats and dogs. It's owned. That's the specialization. Example is done being specialized on owned. And it has math inside of it to deal with owned objects, with the owned.
Right. That's where the type itself, however, is like if I have just an array of ints, just an array of strings, those translate to different classes.
That's correct.
Like one is called array of ints, what array of string. So what happens here, because they are both grouped to the same shape, there's only one version of example.
Right.
But the size method that it calls may be different in implementation-wise for array of int and array of string.
Right. So I assume you have a dynamic dispatch on value.size.
Right.
Yes.
How's that different from an interface and dispatch for which implementation?
No, so the lookup is there. But the compiler still needs to make sure, like, hey, wait a minute. When we create that array of string, we have to make sure that it has a size method specialized for array of string. Right? Because otherwise the call would blow up at runtime because there's no method, right?
Yeah, of course. I mean, that's what template expansion does in C++.
But essentially, so what it does here, when it encounters that array of string, it also looks at like, hey, what dynamic dispatch call sites? What are the methods of array that are called through dynamic dispatch? Here we'll see, that is size, because we call size on the value argument that requires the size interface. So then it says, oh, you know what? Let's also specialize that size method for this newly created array of string. That way this code is correct. Even though there's only one example method that sort of sits in between main and the call to the size method.
Wait, but you already had everything working. Why would you complicate it?
Right, that's why I'm confused.
We can wrap this up, I guess, next time because we are running out of time.
I wrote you the example with the ownership logic embedded in it.
Right. What I'll do, I'll try to write in sort of English to describe it, and then we can, I guess.
Well,
continue.
the examples would be interesting where you have some sort of conflict, because here I just say you did a dynamic dispatch call against size.
Right.
You get two implementations of size. You already wrote one for array of int and one for array of string, ended up in the dynamic dispatch target for it, which I assume is the same one.
But grouping them by ownit and primitive type, sure, it constrains the duplication, the variation of types you have to create, but ownit still has to figure out which ownit implementation have to call. How?
No,
what are really
dynamic dispatch? Like it's the 14th method. Just call. Like, what's the problem?
Right. The size call there is determined by value alone.
Right, so the size call here essentially compiles to
reload the array length, whatever, I don't care.
Class methods. Hold on, it's
methods at the size or whatever.
Yeah, and then it's like was it class dot methods dot size -1 hash code. That's essentially dynamic. This hash code is compiled at
basically
computer that compiles it.
You can
that's basically the same.
Yeah, I was going to say, you can imagine this as, I just did a string lookup on a hash table mapping size as a string name to the code I'm going to execute for it.
Right.
So
the whole, the lookup part solved the problem, works today, not the issue. It is more that if I have a dynamic dispatch call site, I may end up dispatching two generic methods, right?
When you say generic methods.
So methods that have to be specialized.
Methods that are generic in the get this straight here, generic in the ownership rule handling. I claim no, at least not.
Well, no. So let's say I have an array of int and an array of string. They have a size method. The implementation of size may differ, based on the values of the array. If I cast both to the toString or size interface or whatever, and I then call dispatch. The lookup logic is the same, but the method they dispatch to is different, right?
Yes.
Yeah, different types.
Yes, but
the compiler has to make sure that those different versions, those different specializations actually exist.
Yes.
Right.
So the call from my example owned version knows that value is owned. Now I call size on it. So all the things that are the size interface that have the little size have to have an owned specialized version. Without further,
in this case, the example method is specialized.
Yes. But remember the rule that I got from you was that there are no generic ownerships. Right. So when I start with example, it's generic. When I have specialized it by its first argument, it's not generic. Therefore, all functions inside of it are no longer generic on specialization. They are all known. So right here, I know that size is really size owned of ints or string, array of int or array of string or whatever. But it's always the owned version of size.
Yes.
Okay.
That's a specialization by first argument.
As soon as you go generic on the runtime type, all rules are off, all bets are off, things explode.
Yeah, I think I have to write this down, because at this point, I don't want to explain it the wrong way.
Okay, fine. I mean, so sounds to me like you need to make an example where what I'm talking about is broken, and I'm going to immediately take that example and say, oh, but you have generic rules, and now all bets are off, and you're just stuck in the exponential code growth path, and maybe you want to rethink your strategy.
Right.
If instead it's in fact what you're saying, it's all statically determinable, then you should be able to push this through the standard work list algorithm and get up a finite list in reasonable time, and you're done.
Right. Yeah, I'll set up an example, because otherwise we're here for another.
Yeah, we're here forever. It's already 12. Yep. Okay. Anyone? Let me stop share. And anyone else want to have any last questions or comments? Then I'm going to claim an interesting discussion in a lot of ways, and I'm looking forward to next time.
See ya.
Bye-bye.
Thank you all.